Good morning everyone. Welcome to all four e-learning classes. This is zoology subject, chapter 3, session 9. Now we'll go for the discussion of the HDN and HDNB, or else it is said to be the erythroblastosis fetalis. So we have discussed the what is the RH blood group, and we have discussed the HDN, that is hemolytic disorder of newborn, hemolytic disorder of the fetus and newborn, which is also erythroblastosis fetalis. Fetus in the sense the growing embryo inside the mother. It's an embryo which is growing. So in this connection, HDN, erythroblastosis fetalis, is a condition results due to genetic incompatibility that show the consequences in the fetus. It is due to the Rh positive father, and it is the genetic incompatibility that results between the Rh positive and Rh negative woman, which means this is results in genetic incompatibility. That is, we have already discussed that the inability of the existence of the two different groups is what leading to genetic incompatibility, is nothing but the genetic incompatibility definition. The consequences are hemolytic disorder of newborn, hemolytic disorder of the fetus and newborn, that is erythroblastosis fetalis. So the genetic incompatibility consequences are these. It is said to be an alloimmune disorder. It is said to be the alloimmune disorder. What do you mean by this? Alloimmune in the sense there are the immune responses that as against the antigen takes place, the production of the antibodies as against the antigens. The Rh antigen which is present most of the population, or we have seen it's a percentage wise among the whitish, it is varied from 85 to 99% of population prone for or with the Rh antigen. Rh positive and Rh negative are phenotypically normal, but the blood transfusion and the pregnancy time, it shows the genetic incompatibility, shows the abnormal consequences that results in a HDN, that is in the fetus. How now we'll see. In this connection, what I am saying is, it is an alloimmune disorder. Basically, the disorders can be related to the immunity, autoimmune and alloimmune. Autoimmune, and the another is said to be the alloimmune. Let me clear you this. That is the autoimmune in the sense, if the body failed to recognize its own cells and go on showing the immune responses, destroying the cells of its own, is what named to be the autoimmune. Here, that is the body itself what start fighting against its own cell. Alloimmune in the sense, auto means self, whereas the alloimmune in the sense within the same species but different individual. Look at here, these two are two different individuals of the same species within the human beings. They are two different individuals. That's what it is named to be alloimmune. The man and woman who are different individual, and the genetic incompatibility results in a consequences what name it to be the alloimmune disorder. So HDNB or HDN, erythroblastosis fetolis, is said to be the alloimmune disorder, as it is the consequences, harmful conditions are seen, nothing but the hemolytic anemia as well as the jaundice are the symptoms seen, where RBCs are ruptured leading to agglutination and the fetal death. These consequences are said to be the alloimmune, as it involves two different individuals, not within the body of the one individual. Rh antigens have come into a pregnant woman from a man, another individual. So this is what it is said to be the alloimmune disorder. So HDN, HDNB, erythroblastosis fetolis is the consequences in the genetic incompatibility. This consequences is the genetic incompatibility between the Rh negative mother and Rh positive fetus, and this Rh positive fetus is positive because of the father is Rh positive, Rh antigens. For suppose it may be with the R1 or else R0, any of the dominant alleles, and Rh negative. So father is Rh positive, mother is Rh negative. What genotype seen in the baby? It is none other than R1R, that is heterozygous. So the baby born are heterozygous Rh positive, heterozygous Rh positive. Now this fetus is with the Rh antigens, and look at here, a woman is Rh negative, and generally the baby is growing in the mother. The baby is a fetus growing in the mother is Rh positive itself, Rh positive. So the consequences between the fetus with that of the mother, how? Already we discussed that the agglutination is what the clumping of the blood of the two different blood groups. Rh antigens are present in most of the population, but Rh antibodies do not exist naturally. Rh antibodies are IgG type. These are IgG type of antibodies. We have discussed that the immunoglobulins antibodies are of IgA, D, E, G, M. So in this connection, the Rh antibodies comes under category IgG. So these Rh antibodies are produced when Rh positive receive donor. Here this is the what is called the fetus is Rh positive, as father is Rh positive but mother is Rh negative. So here there is a contact between Rh positive fetus with that of the Rh negative mother. How? We know very well that is the mother immune system is sensitized, as the fetus and fetus get connected with the mother by means of placenta. So this Rh antigens that are present in the fetus will expose to the mother immune system. How? Gestation period, generally 38 to 40 weeks of the time period, intrauterine period, the inside the mother the fetus grow, during which the nutrients are being supplied as well as protection. Next, the gaseous exchange is all what takes place through a intimate associated structure named to be the placenta. This placenta will rupture during the what is called childbirth or else during the parturition. Parturition is a phenomenon where the baby take birth. So during this parturition, after the completion of the gestation period, the placenta ruptures and the baby come out. The baby take birth. The baby take birth. So this is what the baby generation, during which the placenta ruptured. Then the placenta rupture releases the Rh antigens. Rh antigens are released into the mother. Rh antigens. Rupture of the placenta releases the antigens into the maternal blood circulation. So this released Rh antigen will reach the mother immune system. This is the maternal immune system. So maternal immune system sensitizes. Always keep in mind, as against an antigen, immediately body respond. This is the functional role of the immune system. So as against this antigen, the mother immune system sensitizes and produces the Rh antibodies. Rh antibodies are produced. Rh antibodies. This is the structure of an antibody. So here these antibodies are considered to be IgG type Rh antibodies. I repeat. So at the time of the parturition, the placenta ruptures and antigens are released. These antigens are exposed to the mother immune system, and the mother immune system sensitizes, produces the Rh antibodies. Meanwhile, the first baby take birth. That's the reason why the first baby is safe. The first baby is safe. Next, the second baby, definitely to these are the parents, as the father is Rh positive and the mother is Rh negative. Second baby will also be born as Rh positive itself. Second baby growing inside the mother. So mother immune system already sensitized and the Rh antibodies are there. Look at here, these are the Rh antibodies, and this fetus, second generation baby, is Rh positive. Again Rh antigens are there. Rh antigens are there. So as the first baby birth, during which the mother immune system sensitized and produced the Rh antibodies, but meanwhile the first baby take birth. But second time, as the second time the baby is also Rh positive, naturally the Rh antigen exposed to the mother immune system, so rapidly the Rh antibodies are produced. This produced Rh antibodies are what cross the placental barrier and enter into the fetus. Generally, this is the point to be noted, that IgG antibodies or Rh antibodies that are naturally not produced, and when Rh positive blood, when exposed to the, when Rh antigen exposed to the Rh negative individual, then produces the Rh antibodies. These are small size, large percentage, and these are the antibodies said to be crossing the placental barrier. The Rh antibodies produced in the mother immune system will pass through the placenta. They cross the placental barrier or border and enter into the fetus. Now, the Rh antigens and Rh antibodies. Look at here. What the condition we see is Rh antigen and Rh antibody. Rh antigen and Rh antibodies will clump Rh antigen and Rh antibody. This is an Rh antigen. This is Rh antibody. Rh antigen and Rh antibody clump. This clumping what causes the rupture of RBCs. Rupture of RBCs. So it is nothing but a kind of exaggerated immune response. The Rh antigens and Rh antibodies clump. This results in the rupture of RBC. That is nothing but hemolytic disorder of. What do you mean by lysis? Breaking. What breaking? Blood cells. What blood cells? RBCs are ruptured. This is what named to be the hemolytic disorder of newborn, hemolytic disorder of fetus. Either during the pregnancy time, the rupture of RBCs leading to the death of the fetus, or else even after the birth, neonatal baby, newborn babies may also affect this. That's what it is named to be the hemolytic disorder of newborn or hemolytic disorder of the fetus and newborn. It is named to be the erythroblastosis fetalis. Now we'll also discuss the why it is this term. Okay, this is the rupture of the RBCs and the blood cells what results in the hemolysis of the newborn and fetus and erythroblastosis fetalis. What condition we are observing here? We are observing that RBCs are ruptured. Rupturing of the RBCs named to be results in decrease of RBC, which is named to be the anemia. Anemia. Naturally, body has a protective mechanism. If the anemic condition takes place, the RBCs go on producing. What is the hemopoietic organ? Bone marrow. Bone marrow is considered to be bone marrow. Bone marrow is considered to be the hemopoietic organs in the adults. So, as the RBCs are being ruptured, the new RBCs are go on producing. As the new RBCs are go on producing from bone marrow, from the mother, and also from spleen and liver. Why? Recall your memory. We discussed that early embryonic stage, the hemopoietic organ is yolk sac mesoderm, later spleen and liver. So spleen and liver from which the RBC production takes place, and also from bone marrow. So these production taking place at the same time, they are being ruptured. This continues. So as these are go on producing, an immature staged erythroblast accumulate in the body. Immature erythroblast or what go on accumulate in the fetus. That's what it is named to be the erythroblastosis fetalis. So the genetic incompatibility between the Rh positive husband and the Rh negative mother results in a baby with the Rh positive heterozygous status. This Rh positive fetus have an intimate contact with that of the mother by means of a placenta. This Rh antigens in the fetus, while the childbirth the placenta ruptures. Ruptured placenta releases the Rh antigens into the maternal blood circulation, and these Rh antigens that are released into the maternal circulation reach the mother immune system and sensitizes the mother immune system, and that produces the antibodies named to be the Rh antibodies, which are IgG type, and this is considered to be the largest percentage type of the antibody of all the 5 types we have discussed. This IgG is the large percentage type of, which means they are smaller in number and are produced large number. As they go on producing, so antigen antibody clumping takes place, lead to the rupture of the RBC. That's what it is named to be the hemolytic disorder of newborn. Before the sensitization of the mother, the first baby take birth. So first baby is safe. When the first baby is safe, when the mother become pregnant for the second time. So the fetus again Rh positive to the same parents. This Rh positive fetus with the Rh antigen reach the mother's sensitized immune system. So the antibodies go on producing. As the first time it doesn't happen, but second time already mother immune system is sensitized. So this Rh antibodies cross the placental border and reach the fetus, where Rh antigen and Rh antibodies are what come across, leading to antigen antibody complex that ruptures the RBCs. This is leading to agglutination and ruptures the RBC, which is what named to be the HDN, hemolytic disorder of fetus, hemolytic disorder of fetus and newborn. And as the RBCs are go on rupturing, as against this, so RBCs reduction is named to be the anemia. To compensate this RBCs from bone marrow and spleen and liver, the RBCs go on producing, go on rupturing, go on producing, go on rupturing. This continues. In this connection, immature staged erythroblast cells will accumulate in the fetus. That condition is what named to be the erythroblastosis fetalis. That's what. So, the genetic incompatibility results in the consequences in the baby. That is nothing but the HDN or HDNB or erythroblastosis fetalis. It is an alloimmune disorder which is developed in a Rh positive fetus because of the Rh positive mother and Rh negative, Rh positive father and Rh negative mother. So by this you come to know that the first baby, all the babies that are born to these couple are Rh positive itself. The first baby is safe. From second generation and onwards, prone for this HDN, HDNB or erythroblastosis fetalis. So, what are the symptoms in this? The newborn baby, if it is the baby born, if a fetal death does not occur, if the baby born suffer from 2 symptoms, name it to be the hemolytic anemia, and hemolytic anemia as well as jaundice. Hemolytic anemia and jaundice are the symptoms they prone for. That is, liver is affected. Besides that, the RBC's number reduces. That is hemolytic anemia. So this is what the consequences. By this, what you come to know, the Rh positive husband, Rh positive man and Rh negative marriage is not suggestible. It is not suggestible. The due reason is this results in genetic incompatibility and prone for the consequences results in HDN, HDNB, erythroblastosis fetalis in the fetus or the newborn. You may raise a doubt. Is that only the condition? Already we discussed that the consequences are seen now. One reason is a blood transfusion and second is a pregnancy. Now the question is, what is the remedy for this? is that majority of the population are Rh positive itself. If the woman found to be Rh negative, is that the baby from second generation and onwards will prone for the HDNB, HDN erythroblastosis fetalis? No. Then what is the remedy for this? The only thing is that generally Rh antibodies must be given. Rh antibodies or the anti-D antibodies. Anti-D antibodies. Rh antibodies or anti-D antibodies must be given to the mother at the 28th week and 28th week and 34th week of pregnancy. That is, I repeat, at the 28th week or 34th week of the pregnancy, mother must be given with Rh antibodies. Now, what it happens, or else even as soon as the childbirth occurs, Rh antibodies is to be given to the mother. Then, what is the idea here is preventing the mother from sensitization. I repeat, what is the consequences we observe here? Hemolytic disorder of the newborn. How? As against the Rh antigens of the fetus, when it exposed to the mother immune system, this causes the sensitization and produce the antibodies. If this sensitization is prevented, naturally all the babies, as long as the mother is pregnant, so long the baby is born, will be safe itself. I repeat, if this sensitization is prevented, the second baby is also like first baby or not? Yes, definitely. Why? This is if not, the first baby would have been prone for this. Why the first baby is not prone for the HDNB? As before the sensitization, the first child took birth, the baby birth before the sensitization. So that is the point to remember. If we prevent the sensitization of the mother immune system, then the babies go on born or not prone for the consequences. So this is the remedy where Rh antibodies are given to the baby mother as soon as the childbirth occurs, or else by 28th and 34th week, Rh antibodies are to be administered to the mother. So these Rh antibodies will bind with the Rh antigens of the fetus. Generally, here sensitization took place by the Rh antigens of the fetus. If this Rh antigens are prevented from sensitizing the mother by providing Rh antibodies, the Rh antigens of the fetus, which are released into the mother blood circulation, as soon as Rh antibodies are given, this causes the clumping. Now you may raise a doubt, is that not harmful for the mother? Mother do not produce Rh antibodies. Why? As there is no sensitization. So whatever the antigen is there, this administered Rh antibodies will clump, which will be very less. I have already informed you that the recipient here, the mother is not with the Rh antigen and mother is not producing Rh antibodies, then there is no point of agglutination, severe condition. So this is how mother do not prone for any of this condition. I repeat, here the donor antigen and recipient antibody is what the danger, agglutination, or else the donor antibodies, recipient antigen, which is less significance or less importance we have seen. Now the mother do not have the Rh antigen, nor mother is producing Rh antibodies. That's the reason immediate after the first birth of the child, or else by 28th and 34th week, if Rh antibodies are given, mother immune system sensitization is prevented, and that causes the second baby is also normal, and immediate after that, if the Rh antibodies are administered, third baby is also normal, fourth baby is also normal. So as long as the mother wants the pregnancy, this Rh antibodies administering definitely going to be preventing the HDNB. So what the genetic incompatibility not suggestible, I repeat, the what marriages are suggestible is now we'll see. That is none other than pass kare. Look at here. The genetic incompatibility exists if the father is Rh positive, and the mother is Rh negative. This is not suggestible. The marriage between Rh positive husband and Rh negative wife is not suggestible. Next, what are suggestible? I repeat, Rh positive male, Rh positive male, it is suggestible. Next, Rh negative husband, Rh positive wife is also suggestible. Next, if both are Rh negative also, if both are Rh negative, this is also suggestible. So the harmful consequences seen with the combination, the marriage between the Rh positive husband and the Rh negative wife, if the male is Rh positive, female is Rh negative, that what results in genetic incompatibility. This is the genetic incompatibility. Whereas in all these instances, Rh positive, why is suggestible? Why not it is a genetic incompatibility? As the recipient produces Rh antibodies when the recipient is Rh negative. So it is very important to see whether the recipient is Rh negative. If the recipient is Rh negative, if the donor is also Rh negative, no problem. But these cases will be very rare. Why? We have seen that is majority of the population are with Rh positive. So these are what all these three conditions are all considered to be what is called the genetically suggestible. That is, the marriage is suggestible in between these three, whereas this is not suggestible as it results in a genetic incompatibility. The consequences seen in the fetus leading to HDNB, erythroblastosis fetalis. Thank you.